All right, today we will talk about graphing quadratics that are in factored form. This is 3.3 factored form of quadratic functions. Remember that a quadratic function is in factored form. It's written this way as f of x equals a times x minus p times x minus q, where p and q are the x-intercepts. So P and Q are the x-intercepts. They are the two values that are going to make that product equal to 0, because P minus P is 0 and Q minus Q is 0. So the x-intercepts are P and Q. We will review a couple of facts here. The first thing, when you're going to graph from factored form, the first thing to do, so these are really the steps, first thing to do is look at the a value and decide whether it's going to open up or down. So if a is positive, it's going to open up or upward. If a is negative, it will open downward. The a that we're looking at here is the same a that we have in the standard form, ax squared plus bx plus c. And this one, the a is just factored out. So there's a little quick review. If a is positive, the parabola is going to open upward. It's going upward like this, and we'll have parabolas that open downward if a is negative, right? So parabolas opening up, parabolas opening down. Second step to graphing from that factored form, you're going to find the zeros or the x-intercepts. They're going to be P and Q. But to make sure we get the right signs, we're going to set f of x equal to 0, because x-intercept happen when y is 0. You solve the equation. You're going to mark the x-intercepts on the graph. Okay? You're going to find your y-intercept. There's your third step. You're going to find your y-intercept. It says here to change it from factored form to standard form, but I don't usually do that. I usually just replace the x with 0 in the factored form. I find it quicker to just do that. Replace the x with 0. Remember, that's how we find y-intercepts. We replace the x with 0. So I'm going to do it that way. And then you can find the axis of symmetry and the vertex without looking at the standard form as well, because what you can do, so I'll put an or here because you can put it in standard form. Multiply it all out, put it in standard form. Or you can find that axis of symmetry by using the fact that h is the average of the x-intercepts. And once you have the x-coordinate of the vertex, which is your h, you can always plug it back into your function to find the y. So we're going to do it a little bit differently. So you do these 4 things. You determine whether the parabola is going to open up or down. You find the zeros or the x-intercepts and put them on the graph, mark them on the graph. You find the y-intercept. You find your axis of symmetry and your vertex. All right, remember HK is the vertex. H is just the average of the x-intercepts because the symmetry line is halfway between the x-intercepts. And then also, an important note here, remember that you draw the parabola as a smooth curve. You don't draw lines. It's a smooth curve, so it's curving, right? And we're going to look at an example. So fill in the requested information for each function, then draw the graph. So direction of opening. This is 1 times x minus 1 times x plus 3. So a is 1, so it's going to open up because a is positive 1. The vertex, I'm going to find my intercepts next, my x-intercepts. I'm not going to go through them in exactly this order. I'm going to do things a little out of order. I'm going to find my x-intercepts next because this factored form is easy to work with. Remember, your x-intercepts happen when the y is 0. So in other words, you need to solve that equation. Okay, so to get those x-intercepts, we're going to replace the y with 0. We're going to add 1 to both sides of this one, get x equals 1. 1 minus 1 is 0, and 0 times anything is 0. Subtract a 3 from both sides of this, and we get x is negative 3. Negative 3 plus 3 is 0, and 0 times anything is still 0. So if I plug in negative 3 for x, look at what happens. Negative 3 take away 1 is negative 4. Multiply it by 0, because negative 3 plus 3 is 0. It works out to 0, right? So our x-intercepts, or our zeros, are going to be 1, 0, and negative 3, 0. Now, if you're working in big ideas, they only will ask you for the x value. They won't want you to write it as an ordered pair. They would just say x-intercepts are 1 and negative 3. So be aware of that. Okay? We're going to write them most of the time as ordered pairs, but realize we could write them this way as just x values. So we've got intercept here at 1. We're going to go ahead and put that on the graph like it said in our strategy up there. Okay, decide whether it opens up or down. Find the x-intercepts, mark them on the graph. We're going to find our y-intercept. We could multiply it out, but you know what? I'm not going to, because to find the y-intercept, we just replace the x with 0. That's going to get us y equals, let's see, 0 take away 1, and 0 plus 3. I'm just substituting 0 into my function here. Okay, so we're going to have negative 1 times 3, which is negative 3, right? So we've got a y-intercept here at negative 3. Let's find our axis of symmetry. Here's how we can find the axis of symmetry. We can just average these two. So h is just the average of those two numbers. Now, how do I average two numbers? I add them up and I divide by 2. I want to find the halfway point, because that axis of symmetry has to be exactly halfway between the 1 and the negative 3. It has to split those points in half, because the symmetry line goes right through the middle of those intercepts. So you could even count. There's 1, 2, 3, 4 units, so halfway in between. We split that distance in 2. We'd have 2 units on each side. My axis of symmetry has to go through x equals negative 1. But you can average them because it's halfway in between. 1 plus negative 3 is negative 2. Negative 2 divided by 2 is negative 1. Okay, so my axis of symmetry, I'm going to change colors here really quick for a second. And I'm going to draw in my axis of symmetry. It's the line x equals negative 1. I'm going to go ahead and put that down here. X equals negative 1 is the axis of symmetry, because h is negative 1. Okay, we've got another point over here. Using the symmetry, we can take that y-intercept, take it 1 unit across the line, 1 unit to the line, 1 unit on the other side of the line. Use the symmetry. To find the y-coordinate of the vertex, we're just going to plug in negative 1 for x, and let's see what happens. So go to your function, replace the x with negative 1. So replace the x with negative 1, replace the x with negative 1, and see what you get. So the k value is going to be negative 2 times 2, which is negative 4. So my vertex is going to be the point negative 1, negative 4. Okay? I'm going to circle that up because he's going to get lost in all this. So my parabola opens upward. I have my vertex, negative 1, negative 4. Look, there it is. He's right down below those 2 points. He better be. I'm going to see if I have another pretty point on my graph. Oops, I got one other thing I haven't answered here yet. We've got the factored form. We've got the direction of opening. We've got the vertex. Have we decided whether the point is a maximum or minimum? It's a minimum point. The vertex is a minimum point, and that minimum value is negative 4. The smallest y value is negative 4. So the minimum value would be negative 4. I'm going to do one more point, I think. I'm going to look and see what happens when x is 2. So if x is 2, let's just plug it in. We would have 2 take away 1, which is 1. 2 plus 3 is 5. I'd have 1 times 5, which is 5. So I go through the point 2, 5. Let me count across to the axis of symmetry. 1 unit, 2 units, 3 units, 1, 2, 3. Reflect to the other side. We've got a partner that's exactly on the opposite side of that reflection line. That symmetry line is a reflection line. And then we draw our parabola. There he is. Okay, there's our parabola. Domain is all real numbers. We can either say it in words as all real numbers. We can use the capital R with the extra line instead of all real numbers. Then our range, notice our smallest y value is -4. I'm going to identify that. And we have all y values greater than or equal to that. You can use the interval notation as well as the inequality. So this is the inequality notation that we have written here. I want you to be able to write it with interval notation as well. It would go -4 as the smallest y value. Positive infinity is where we go because it's going to go from -4 up forever. Right? The y values are going from -4 as a low to infinity because it's going to keep going up forever. And that is the first page of our notes.